Good morning and welcome to the solution video to problem C of the 2022 Meta Hacker Cup round 2. This problem is balanced scale. So in this problem we have a bunch of cookies. Most of them are raisin cookies, unfortunately, but there's a lucky batch that is chocolate chip. Now we're going to try and find a big hefty cookie to eat, and we're going to throw some cookies away in the process. And we're going to use our balance scale to try and find a rather big cookie. But we want to know the chance that this cookie happens to have chocolate chips. So there are a bunch of batches of cookies, and we want to see, what's the chance we get one from the first batch? That's the batch with chocolate chips. Now, all of the cookies with chocolate chips will have the same weight, and the process we're going to use in order to find a cookie to eat is we'll randomly start with one cookie, and we'll put it on the scale. Now, k times, we're going to do the following. We're going to first randomly pick a cookie here. It can be any one, uniformly at random. We're going to put it at the empty spot, and then we'll throw away whichever cookie is lighter. So let's say we randomly pick this one here. And obviously we don't know the weights and which ones have chocolate chips when we're doing this, so we just pick uniformly at random. And then we throw away the lighter ones. In this case, that's the 3. The 3 will go into the trash can. All right, so we did this once. Let's do it a second time, just by chance. So let's say we get this 5 here. We'll put this 5 on the scale, so now we have 2 5s. Again, this one has chocolate chips. And we see that, okay, they're the same weight. So in this case, if they are the same weight, we'll always throw away the one on the left side. And we're left with this cookie right here. So this one happened, I forgot to erase this, but you get the idea. So this happens to be a cookie that does have chocolate chips. This is one of the cases where maybe we got lucky. But it just as easily could have been one that doesn't have chocolate chips. Maybe if we started with the 7, we're never going to throw away the 7. So we would end up with a cookie with raisins instead. All right, so how do we actually calculate this? Well, the first thing to notice here is that we can kind of simplify matters a little bit. By instead of having a whole bunch of different batches of cookies, we can imagine there are just 4 batches. So the first batch is the ones with chocolate chips. So we'll call that the CC batch. Then we have another batch. These are the ones that are heavier. So we've got the heavy batch. We also have a bunch of cookies that have raisins, but are equal in weight to the ones with chocolate chips. So we can call this the medium batch. And importantly, all of these have raisins. And then we have a 4th type of cookie, and this is the light batch. So if we ever end up with a heavy cookie on the scale, then we'll never have a chocolate chip cookie at the end. Because we'll never be able to replace that heavy cookie with a chocolate chip cookie. So that's the important part. These are kind of like a really dangerous type of cookie because they can destroy us right away. So we're gonna watch out for the heavy cookies, and then the medium cookies and the ones that are our weight, those are kind of interesting. I guess it kind of depends on which one happens to be on the left side of the scale, because that's the one that might be erased. So how do we solve this problem? What do we do? Well, the first thing we're gonna notice is that this scale process is kind of annoying, right? The left side, the right side, knowing which side things are on, it's kind of tricky. So instead, we're going to look at this from the perspective of, well, hang on a minute, isn't everything here random anyway? If we're picking some set of cookies that will be at some point on the scale, and we're picking them in a random order, there's just as big of a chance that something will be on the left side as it will be on the right side. Because everything's more or less symmetric. So we can actually kind of ignore the scale for now, and instead we're going to imagine we have a set of cookies, and we're going to look at k plus 1 of them. We want to know what are the odds that the first cookie we look at, that's the biggest, has chocolate chips. And that's a similar and much easier problem to solve. So we just have k plus 1 cookies, right? We're going to pick a random k plus 1 of the n cookies. And we want to know what is the chance the biggest one, then the first one of that biggest weight, has chocolate chips. It's totally equivalent. So that's the first thing to convince yourself of. Okay, so we're going to get rid of the scale in the trash can then. Well, how do we actually calculate this? So the first thing we can see is we can figure out the chance of getting a heavy cookie. We know we're going to pick k plus 1, and we know there are n cookies, so this might be 100%. And if it's not, we can figure out exactly what the chance is. We can do this with basic combinatorics. So we just have n choose k. And we know this formula is equal to, if you have n things, and you're going to pick k of them, this is equal to n factorial divided by k factorial times n minus k factorial. So we can use this, and to do this division, we can use the mod inverse. So we can use multiplicative mod inverse. Okay, so that's the chance, we know the chance that there will be a heavy cookie. And for all of those cases, we know we're not going to end up with a chocolate chip cookie. All right, so then the other thing we were interested in is, what is the chance that all of the cookies we pick happen to be light cookies? They all happen to be too light. Well, we can do that again with n choose k, right? So we know what are the odds that if you pick k cookies, they're all in this light group. We know how many are in this light group, and we know how many cookies there are. All right, so this is, we can just use this again. That tells us how many light cookies there are. The only other case that's left is with these two here. And the important thing to notice here is that these cookies are basically the same, right? There's no way of distinguishing them. It doesn't matter which one happens where. We can basically just pick a random one uniformly at random. If there are no heavy cookies, we're going to end up with one of these, and they're all equally likely, because everything is symmetric. So we just say, okay, if there are, let's say, 3 of these and 7 of these, we have a 30% chance that the one we end up with is here. It doesn't matter how many light ones there are. As long as there's at least one medium weight cookie, there's a 3 out of 10 chance that we end up with this one here. So this was a bit of a mathy problem, but overall it was like surprisingly achievable. The only thing you really had to know ahead of time was some basic combinatorics. It had to do division under mod. And this is important because a lot of times the answer ends up being very, very close to 0 or very, very close to 1. And if we just had you print a double, it would be very hard to distinguish answers that are correct from like just kind of ones that are guesses. So that's why the mod inverse exists. Helps avoid precision issues caused from doubles. Anyway, that's all for this problem. I hope you enjoyed, and I'll see you in the next problem in the contest, problems D1 and D2. Thank you for watching. Goodbye.